I'm Justin Ryburn. I'm the Vice President of Global Solutions Engineering here at Kentic. This section, we're going to talk about observability across the enterprise. I'm guessing some of you have worked on networks that, if you were to draw it up on a whiteboard, would look something like this. I know I for sure have. We like to say we know 3 truths about enterprise networks, and those are that they're becoming more and more complex over time. As we see trends where people are migrating from on-prem workloads, their workloads are migrating into the cloud. That doesn't happen overnight. So then you wind up in this hybrid cloud where you've got some of the application workloads running in the cloud. You've got some in your on-prem data center. They have to be able to talk to each other. They're becoming more and more critical. All over time, when the network is down, the network is responding slowly. You're getting more and more complaints about it. It's not something, when I first started in IT 25 years ago, if the network was down, only a small handful of people cared. Now they're basically mission critical for the businesses that we support. And customers. Now, enterprises may not technically have customers that are buying a service from them, but they very, very much have people who care when the network, again, is not performing. There's a slowness to the network. There may be internal users, but there's definitely customers of the service that the enterprise network teams are providing. And so what is the advantage that Kentic brings to the table? And it's again, we've talked about the various different telemetry types that we have. But what I'm going to focus on in this presentation is really about the different types of networks that we can look at. So we can look at the data centers, we can look at the SD-WAN, we can look at WAN, we can look at public cloud, we can look at containers, we can look at the internet, we can see how traffic's routing for you on the internet. Provide that large volume of data with that context, be able to see what's really going on and answer a lot of those questions, provide the proactive insights that Phil talked about in the previous session. And again, be able to answer questions really quickly. As Phil showed, you were able to dive from an insight down into something more detailed to really figure out what's driving an alert or an insight that pops off in the tool and have access to all of that data. You're not constrained by pre-built views that if you didn't think to build it in advance, you're blind to that type of data. We give you the ability to dive down and look at all the metrics, all the dimensions, all the queries. Couple examples I'll show here on the screen, and then I'll get into a demo and actually show this live in the product. One of the more powerful visualizations that we have is the ability to visualize your cloud environment. So once you start migrating those workloads up into the public cloud, you need to be able to understand that network the same way you understand your data center network, your branch network. You need to be able to understand what's talking to what. And those are very different networks that are in the public cloud than what you had on-prem. You have things like VPCs and transit gateways, direct connects. I mean, you have to understand all of that, and then you obviously have to be able to troubleshoot that when somebody calls, like I'll show in the demo, and says, hey, there's a problem. How do I get in to even start looking and trying to figure out where that problem might be occurring and what might be causing it? Security. Well, Kentic's not technically really a security product in the true nature and the true sense of the word. There are definitely some security use cases that we see our customers using, especially in the cloud. So looking at things like, how do I go and audit that what I think I have as my security posture in the public cloud is actually what I think it is, right? That was probably easier when you controlled everything and it was in your data center. Once you move to the public cloud, what we see with most of our enterprise customers is they're adopting the native cloud environment security constructs. So they're having to create NACLs, they're having to create things using, say, AWS's native constructs, as opposed to having a firewall where they're used to looking at firewall tables, firewall configs to see what's going on. So how do I make sure when I migrate those applications that my security posture stays the same that it is? How do I shut down bad actors? How do I forensically look at what was going on once I've had a security breach and I want to go back and say, okay, 2 weeks ago when that security breach took place, what did that data look like? What was the data exfiltration? What was the nature of it? What were the applications? What were the ports and the protocols that were involved in that security breach? So there are definitely some security angles and security use cases around our product. All right, when you see all of your telemetry in one place. Bgp hijacks and leaks. So I know not necessarily every enterprise runs BGP or cares about how their routes are being advertised out on the network. But we definitely talk to a lot of enterprises, especially your Fortune 500, your Fortune 100 enterprises that want to be able to keep an eye on they're BGP advertisements. They're prefixes that they're advertising out on the internet. And if those get hijacked by somebody else, or there's a path change, it gets leaked, it can definitely affect application reachability. It can affect data center reachability, branch office reachability. There's a lot of different things that could cause reachability and performance problems in the networks. And then Rpki status, I talked about a little bit in my intro. That's an area of focus that we've worked on a lot recently, where you have the ability to overlay your network traffic on your routing table and see how much of your traffic is going to prefixes that are Rpki valid state, so that you'll be able to catch and easily troubleshoot Rpki ROA signature issues that you may have with your prefixes. And again, all of this, we have visualizations in there, but you can also set up proactive notifications. So it's not like you have to wait till somebody calls you and says, hey, there's a problem, log into the tool and do the troubleshooting. We have the ability to configure notifications, and we'll talk a little bit about that when we get into the demo as well. And then being able to visualize your traffic on the internet, right? Being able to see what are the AS paths that my traffic is taking, get a nice logical map here, somewhat similar to a Sankey diagram, although in this case, we're specifically looking at all of the hops that the traffic is taking through the various ASNs. I know this screenshot's a little hard to see on this screen, but I'll show you a much better one when we get into the demo, where you can see all the paths that the traffic is taking and get clues to help you find where you might have trouble spots that you need to be able to troubleshoot in your environment. All right, so it's one thing to say all these things and to throw up a couple screenshots here on the slides and talk about what we can do, but nothing is better than actually seeing it in the product. So let's hop over and actually see this in the product. This is the Kentic Map that I talked about a little earlier in my intro. So this is giving me the ability to visualize not only my physical locations, my data center, but also cloud. So in this case, we're actually looking at our Amazon Web Services environment. And the user story here is, let's say for the sake of discussion, that I've gotten a phone call from users and they're saying that the applications that they have running in this VPC down here that's called, where'd it go? CA VPC 51 prod. That VPC is not able to talk back to the Ashburn data center. For some reason, there's a subnet there, 10.0, 192.168.9.0, that's not able to talk back to the Ashburn data center and to the databases that I have running in the Ashburn data center. So what I can do is I can start with the Ashburn data center right here. I can look at the firewall. I click on this. It gives me all kinds of different things that I can look at about the traffic that's flowing in and out of that particular gateway in my data center, what device it comes in on, what gateway it comes in on. I can look at all kinds of different visualizations here. But the really cool thing is I can trace these arrows back, and I can see that this happens to attach to a transit gateway in US West 1. Okay, that's a good sign. That's where we're wanting to do our troubleshooting. If I come over here and I look at my VPC, I can see that this VPC has a transit gateway attachment point that's attaching to the transit gateway. So far, so good. I can see I do have traffic that's flowing across there. I could look into the nature of that traffic if I wanted to. But let's do our troubleshooting here. So one of the things that we enrich this data with is the routing table for the transit gateway. Hold on, right? Oh, I'm sorry. Go ahead.
What's the delay on your information that you're showing right now, or is that real time?
Pretty much real time. So actually the data source that's behind this is VPC flow logs from Amazon. And so Amazon, if I remember correctly, they're now up to 5 minutes that it takes for them to export a flow log, put it in an S3 bucket, and then we pick it up from the S3 bucket and ingest it into our system.
Okay.
Pretty much as soon as the flow log is created by Amazon and put in that bucket, we can pick it up and put it into our system.
Gotcha.
And then a lot of this mapping, a lot of the metadata that's behind these visualizations that shows the interconnections of all these pieces, we're using what we call the describe API. So we're basically going and pulling the API and getting that metadata to be able to build these really neat maps and these neat visualizations. And we can do that in real time. All right, so if I think what I was starting to say is we get the transit gateway routing table. So again, via the API, we pull that information, we enrich the flow data with that. So then I can dig in here and say, okay, let's go and take a look at this routing table on this transit gateway. And I can see that I have a number of different prefixes that I have set to route to various places through the transit gateway, out to various different attachment points. Most of these look pretty good, but sure enough, if I come down here, I have one that has an exclamation point by it, which sure enough is the subnet that the user is called to tell me about, which is the 192.168.9.0. Right there, I can tell that that's the reason that that particular subnet is not able to get back to my Ashburn data center. So now I can go into AWS, I can go in and configure that and tell it that I need it to go across that attachment point back to my Ashburn data center. So really quickly, I can get from the user complaint to root cause of what's causing that routing issue in my environment. So for the next scenario, let's say for the sake of discussion, if I go back up to my top level of my map here, and again, I can see all of my cloud environments. So we were just looking at Amazon, but I'm up one level. So now I can see all my particular cloud environments. I can see the internet that I'm connecting to, and then I can see all my various locations. And each one of these blocks, you can see how much traffic you have between them. So between the public cloud and the my on-prems, I have 314 meg of traffic going up to the cloud, 16 gig of traffic coming from the cloud back to my different sites. There's a lot of different things I can get a quick visual of how my traffic looks. But let's say for the sake of the second scenario here, we get a call from some users that are saying that the San Jose data center has a 10.0.1.0 subnet that is not able to talk to anything else in that subnet. So this is an on-prem data center problem. So if I click over here on the West Coast and drill down into Northern California, go down into the Southern Bay Area here, and I can see I have this Acme SJC1, which is my San Jose data center. I can go and look in that site and see my topology. Now I have a similar view to what I had on the last screen, but this is specifically the topology inside of this one data center. So I can see my spine leaf architecture that I've got. I can see my various switches and how they're connected. But then in the other blocks, I can see where I have traffic going to other sites, where I have traffic going up into public clouds specific to this particular environment, how much traffic I have flowing between them. And then, of course, how much I have going in and out of these sites to the internet. But again, we came here to troubleshoot this one subnet. So let's go in here. Let's add a filter. I'm going to look at the CIDR block of 10.0.1.0/24, because that's what they said they were having an issue with. And now it's highlighting. You see the little pink lines that are glowing there. That's actually highlighting that traffic. So I'm filtered just looking at the traffic on this one subnet and how it's actually flowing through my spine leaf architecture. And so at a quick glance, I can already tell I've got a little bit of a problem here because I have traffic going leaf to leaf, which shouldn't do that, right? Spine leaf architecture, your traffic should have to go through the spine to speak to each other. You shouldn't have these leaf to leaf communications like this. So it gives me a quick, at least if it's not root cause, at least gives me a quick way to figure out that that's probably where my issue is. I've got some misconfiguration with the way this traffic is routing inside of this data center based on what I'm seeing here on this visualization. So this is all cool for looking at what is going on in the network, but what about?
I really have to say, you have awesome users that create a ticket about specific subnets between two locations. I just want to work there.
Right.
I'd
Right.
train them.
You wish you had those kind of first world problems where they know what subnets are their applications are actually running on.
Yeah.
Yeah, sure. I can dig down and see like what applications, if I have proper enrichment. I don't know if in this demo environment I will have that, but that's a bad example. But some of these links I can actually look at the traffic, or I could jump off into our data explorer and see what types of applications are flowing across. Now, a lot of times, if I don't have the proper enrichment, that'll just be HTTP, 443 traffic. It'll be port 80 traffic. But if I have business context enrichment, if I have application context enrichment, then I can actually look at those links and see what applications are flowing across those links. So there are other ways and other constructs that I can use to do that troubleshooting. Phil talked briefly in his presentation and his demo about synthetics, but I was going to walk through another scenario related to synthetics, which is a slow application. So in this case, it's not down. It's not that it's unreachable. It's that we're having slow page load times. We're having this application that's loading really slow. And so one of the synthetic test types that we can do is the ability to do a page load test, see how long it takes for that page to load. If I click on this slow web application test type, what I have going on here is I have 3 agents that I've deployed. In this case, they're private agents, but we have a whole footprint of global agents as well. So there's 2 different types of agents that we can use in our synthetic product. Private agents that you might deploy in your own infrastructure, in your own private data center, at your branch locations. Maybe it's running on a Raspberry Pi at each one of your branch locations. So you can have them inside of your own environment, or you can use the ones that we have hosted. They're what we call global agents. Those are what we see with most customers they're using for what I call outside in testing, where they want to test from various places on the internet back to the application. Either way, what we have here is 3 agents that are testing to this particular web application we happen to have running up in Amazon, which I can tell by looking at the URL. And I can see over time what the performance of that was. So a lot of times, it's green, everything's healthy. We can see we have a 200 status code down here. You can see your navigation time, your connect time, your response time. So we're breaking out various different parts of that HTTP transaction to see how long it takes for the TCP connection to set up, how long it takes for the page to load, and so forth. But to find something more interesting, let's look at some place where it's critical, where it's not healthy here. At 21:15, looks like we had an increase in the HTTP latency. If I click on the details, we'll go down and we'll take a little bit more deeper look at this one particular test. This is one agent connecting to that application. Again, at 21:15, we do see that we were outside of our standard deviation for latency. So you can see your rolling standard deviation metrics there. We were 542, and so we're outside of the window. But then we can go up here and we can see what actually made up that increase in that HTTP load time. So the key outlier here looks to be DOM processing time. So we'll dig into that a little bit more in just a second. But one other thing I want to show is we can click on path view, and then we can see over time changes in the path. So if there was a network event that took place that caused our routing to change, maybe there was a BGP announcement, routing change, maybe it was an internal routing change that took place, I could visualize that on here. Doesn't look to be the case here. If I kind of mouse over the time frame of 21:15, I don't see a lot as far as changes in my path. So that doesn't seem to be my smoking gun here. That doesn't seem to be my root cause. So let's go look at the waterfall. Let's go look at all the various parts of this web page and let's see how they were each loading. Again, go to my critical time here, 21:15, and I can see all the various pieces of that web application. And down the side here, I can see how long each one of them took to load. And so it appears that the one that took the longest to load was this particular file right here. And if I click on that, I can get more details about that file, how we requested it. It's sitting behind a load balancer and Amazon. I can even give my application team that URL and tell them, hey, this is the one piece of that web page that seems to be loading really slow periodically when we're having these type of problems. So helps me really dive down and figure out what part of my application it is that's loading slow and causing my performance issue. All right, one more thing, BGP. So if I go, actually, I think I already have it open in another tab. One of the things that we can also do with synthetics is actually, it's not technically a synthetics test, I guess, although we organize it in the UI and that part of the product, is look at BGP monitoring. As I mentioned in my slides, we can look for BGP hijacks, BGP route leaks that are taking place, proactively notify you of that, as well as visualize it in the product. So here's an example of a scenario where this particular company called Turnitin has a /21 that they advertise out to the internet. That's all fine and well. You can see down here at the bottom, you have Turnitin, they're advertising it. You can see the entire path it takes if I go backwards up to the tier ones are the main backbone providers that are advertising that out onto the internet from our vantage point. I can see what the path is for BGP announcements from them back into the internet, if you will. But I can also see that there's this company called Indosat that is also advertising that /21. So they've actually hijacked this route. They're actually leaking it to Anycast networks. So I can actually see really quickly that the /21 that I'm monitoring, not only am I advertising it, but there's somebody else that's also advertising it out onto the internet. And that, is potentially an issue that I want to be aware of. I want to be notified of proactively so that I can contact them and get that cleaned up. All right, I think that was everything I had. Are there any questions before I hand it over to Brian for our last presentation?
Just real quick on that BGP path visualization. It looked like it was VP's Vantage Points. That's where you're observing this from.
Yep. And I can dive into that and see more details on each. Oops, yeah, so we have what we call Vantage Points, which is basically where we're observing these routes from various different places across the internet. A lot of them come from route views, ripe data, but then we also have a lot of the customers that have BGP sessions with us because they're looking at, they're doing BGP enrichment. So they're sending their tables to us to enrich their net flow data with their own BGP tables for looking at their own network. And so we have a lot of those customers who have allowed us to use their data. It's obviously anonymized, but we look at their tables in addition to the publicly available Vantage Points. So there's a combination of private Vantage Points and public Vantage Points, if you will, that we're doing this from.